Today we're going to take a closer look at solving linear equations. Specifically, we're going to be looking at equations that have fractions and decimals in them. So we'll start with an example. Y minus 1/8 equals 5/6. Now if we want to get the y by itself, we would have to get rid of that minus 1/8, which means we could add 1/8 to both sides. So y equals 5/6 plus 1/8. Now to add fractions, we have to find a common denominator. So we have to figure out what number is divisible by both 6 and 8, and that number is 24. So I'm going to take 5/6, multiply the top and bottom by 4, and I'm going to take 1/8, multiply the top and bottom by 3. That gives me 20/24 plus 3/24, or y equals 23/24. Now, as the equations get a little bit more complicated, it's going to be helpful to learn another technique that we can use anytime we have fractions in an equation. It turns out we can clear the fractions, or we can get rid of fractions in an equation by multiplying every single term by the least common denominator. I'm going to show you how this works with example 1. You don't need to write this down in your notes. We're going to do a lot of other examples. But the basic idea is you still have to find that least common denominator, which is 24. And then the idea is you take every single term and you multiply it by 24. So 24 times y, 24 times 1/8, and 24 times 5/6. Now this 24 is really a 24/1. And so when I multiply, I get to reduce. 24 divided by 8 is 3. 24 divided by 6 is 4. And I'm left with the equation 24y minus 3 equals 4 times 5, which is 20. And then this is something that's a little bit easier to solve. We could add the 3, and then we can divide by 24, and we get the exact same answer. So I want to focus on this new method, clearing the fractions, by multiplying everything by the least common denominator. So in example 2, there's only one fraction in that problem, so my LCD, or my least common denominator, is 9. So I'm going to start this problem by multiplying both sides by 9. On the left-hand side, I get 72. And on the right-hand side, the 9's cancel out, and I'm left with negative 2w. Now I can finish the problem by dividing both sides by negative 2, and so my final answer would be w equals negative 36. Let's try this method on some slightly more complicated equations. I'm going to start by finding the LCD, so I need to figure out what number is divisible by 12, 8, and 4. If you know what that number is off the top of your head, it's 24, then that's great. If you don't recall, you can always make these factoring trees. 12 is 3 times 2 times 2. 8 is 2 times 2 times 2. And 4 is 2 times 2. And then the LCD has to contain every single factor of every denominator. So I start by listing all the factors of the 12. And then I move over to the 8. 2 of the 2's have been written down, so I just need to add the third one. And then I look at the 4. Oh, both of those 2's have been written down. So 3 times 2 times 2 times 2 is 24. So I'm going to take every single term in that equation and multiply it by 24, or 24/1. Now I can reduce. I can actually get rid of or cancel out the denominators. 24 divided by 12 is 2. So that first term becomes 2 times 7, which is 14k. 24 divided by 8 is 3. 3 times 5 is 15. So the second term is 15. And 24 divided by 4 is 6. 6 times 3 is 18. And now I have an equation that's a little bit easier to solve. To get the k by itself, I have to subtract the 15. So 14k equals 3, and then I would divide both sides by 14, and k equals 3/14. Now, if your equation has parentheses in it, I recommend that you get rid of the parentheses first. It just makes that second step of clearing the fractions a little bit easier. So I'm going to distribute the 5, and I get 5n minus 5/4 equals 5/3. Then I have to find my LCD. In this case, it's 12. 12 is divisible by 4 and 3. So I'm going to take everything in the equation and multiply it by 12. The first term becomes 60n, 12 divided by 4 is 3, so the second term is a minus 15. 12 divided by 3 is 4, so that last term is 20. And now we can solve the equation by moving the 15 over and then dividing both sides by 60. In this case, I'm going to have to reduce for my final answer. 35 and 60 are both divisible by 5, and so I'm left with 7/12. All right, let's do one more example with fractions, and then we'll move on to decimals. I'm going to start by finding the LCD. My denominators are 4, 12, and 9. I have their factors listed. I'm going to include both of the 2's from the 4. I move over to the 12. I already have both 2's written down. I need the 3. I move over to the 9. I have one of the 3's written down. I need the other 3. And I get 36. So I'm going to take every single term in this equation and multiply it by 36. Denominators should cancel out. 36 divided by 4 is 9. 9 times 7 is 63. 36 divided by 12 is 3. And 36 divided by 9 is 4, so minus 20p. So to solve, I'm going to get the p by itself. I'm going to subtract 3. 60 equals negative 20p. We can finish by dividing both sides by negative 20, and my final answer is p equals negative 3. Now, if you have an equation with decimals, it turns out you can actually clear the decimals as well. If your equation, like in example 1, just has decimals with digits in the tenths place, we are going to multiply the entire equation, every single term, by 10. Multiplying by 10 takes the decimal and moves it over one place to the right. So when I multiply in each of these terms, that decimal is going to be moved over one place to the right. Now I have to deal with that x term as well. I have to multiply the x term by 10 as well. So let's see what we get. When we multiply negative 4.5 times 10, that becomes negative 45x. 1.2 becomes 12. Even though that x term doesn't have a decimal with it, you still have to multiply it by 10. You have to multiply every single term by 10. So that becomes a 10x, and then plus 7. And now this is something I can solve. I'm going to put all the x's on the left. And then I want to get x by itself, so I'll subtract the 12. And finally, to finish, we're going to divide by negative 55. And I'm going to write my answer as a reduced fraction. So this is going to be a positive 1 over 11. We can do the same thing in example 2. All of the decimals have digits in the tenths place. Now note, if you have a decimal with a digit in the hundredths place, you would multiply by 100. The idea is you can move the decimal as long as you're doing the exact same thing to every single term. So I'm going to multiply everything by 10. That moves the decimal one place to the right. And I have to multiply that 2 by 10 as well. It becomes a 20. And on the right-hand side, I get 12 minus 3x. Now I can solve like I normally would. I'm going to put the x's on the left. And then I'll get x by itself by moving the 20 over. And finally, I'll finish by dividing by 8. And my answer is x equals 4. Now I also want to show you a couple of special cases that occur when you're solving equations. So let's take a look at example 1. Let's just go through the process that we've learned in the past. We're going to get rid of parentheses first. And then I'm going to combine like terms. And then I'm going to try to put the x's on one side. So I'm going to subtract 8x to try to put the x's on the left. But what happens here is 8x minus 8x is 0. And I'm just left with a negative 1 equals negative 5. The x's disappeared. That's what makes this a special case. Negative 1 doesn't equal negative 5. I'm left with a false statement. That tells me that this equation has no solution. In fact, anytime the x's disappear and you get a false statement, you can always stop and you just write on your paper, no solution. This equation doesn't have a solution. Example 2 is going to illustrate my second special case. So let's get rid of parentheses and then combine like terms. 1x minus 3x is negative 2x. And then we'll do the same kind of process. If I want to put the x's on the left, I'd have to add 2x to both sides. And once again, the x's disappear. But this time I'm left with a true statement. Negative 4 always equals negative 4. What that means is x can actually be anything. You could plug any number in for x, and this equation would always be true. And so what we're going to write down as our answer is we're going to say that x is all real numbers. The idea is x could be anything, and the equation still works. So those are our two special cases. Again, they occur when the x's disappear in the equation. Finally, the last thing I'd like to show you today is how we can take a formula, something that doesn't have numbers, and solve it for a variable. And it turns out the math that we're going to use is the exact same as the math we've learned earlier. So if we start with the example A equals L times W, and I want to solve for L, I have to get rid of that W. Because the W is being multiplied, I'm going to divide both sides by W. And that gives me A divided by W equals L. And that's it, I'm done. I'll put the L on the left because that looks a little bit nicer. But that's my answer. You can also deal with formulas that have fractions, and just like we learned in today's lesson, you can clear the fractions by multiplying everything by the LCD. In this case, the only fraction is 2, so I'm going to multiply both sides by 2 to try to get rid of that fraction. That gives me a 2a on the left, and on the right, the 2's actually cancel out, and I'm just left with b times h. Now we're solving for b, so I have to get rid of the h. It's being multiplied, so I'm going to divide both sides by h. And that's it. I'm done with the problem. I'll rewrite my answer. B is 2a divided by h. So the steps are the exact same. I think the nice thing is, since you don't have numbers, you don't have to deal with doing any arithmetic. All right, last example, let's solve the formula 2x plus 3y equals 6 for y. So if I want to get the y by itself, I have to get rid of that 2x term. I need to move the 2x term to the other side. I'm going to do that by subtracting it from both sides. That gives me 3y equals 6 minus 2x. Or you could write 3y equals 2x minus 6. The order you write those terms in doesn't matter. Now the 6 and the 2x are not like terms, so we can't combine them. But to finish, we're going to divide everything by 3. And there's two ways you can write your answer. You can go with a large fraction bar like that, all divided by 3. And your answer would be y equals 6 minus 2x divided by 3. And you can leave your answer like that. Or you can divide each of the terms individually by 3. And that's probably how I would do this problem. That would give me y equals 6 divided by 3 is 2. And then I'll just leave the second term as a 2x minus 3. Again, the order of those terms doesn't matter. That's it for today. I know there's a lot in this lesson. Please let me know if you have any questions.